Hello, third grade. We are going to get started with our math instruction video for today. We are going to be going through investigation 9. So if you watched yesterday's video, I said if you wanted to work ahead and cut out some of those manipulatives, that'll help you out for the investigation. If you have not had a chance to do that, you might want to pause the video and take a chance to cut out those halves, quarters, and eighths that were included in the packet. That's what investigation 9 looks like. And then the one-sided manipulatives were included right after that. This is at the very end of your Learn at Home Packet 1. Today, the objectives that we are covering are using fraction manipulatives to model, compare, and order equivalent fractions, use fraction manipulatives to add and subtract fractions, use fraction manipulatives to model mixed numbers, and use fraction manipulatives to explore how fractions, decimals, and percents are related. Our theme for that investigation, investigating fractions with manipulatives. And if you caught on to the theme with all of those objectives, each one of them was specifically stating using manipulatives. Manipulatives just mean things that you can move. So it is taking what we have already learned about fractions, what we've already learned about percents, and practicing it using things that we can move around. So I've already cut out all of my manipulatives, and because I was bored, I colored them as well so that it would stick out when we're using different fractions to show equivalent fractions. So you might notice that on your manipulatives, it says 1/2, but then it also says 0.5 or 5/10, and then it also says 50%. So on each of your manipulatives, it will tell you what is the equivalent decimal, what is the equivalent percentage. So then on my quarter decimals, on my 1/4, it says 1/4. It says 25 hundredths. And it also says 25%. And then on the eighths, it says 1/8, 125 thousandths, and it says 12.5%. And we're going to be using these manipulatives to model some of these fractions, decimals, percentages, and then figure out things that are equivalent, and also do some with mixed numbers. Now that was an oops on my part, because normally, investigations are a math thing that we do all together as a class. Normally, everybody would be given a sheet of halves, a sheet of quarters, a sheet of eighths to cut out. And then you'd be sitting in your desk group, and when it came time to do mixed numbers, it wouldn't matter that you only cut out 2 halves. Everybody in your group would have 2 halves so that you would have more halves to show mixed numbers. So some of those mixed number things, I'm going to need to just show you the example because you don't have more than one set of each manipulative, but I do here at my house. So we're going to get started, and normally I would be picking on somebody to read for us. We're going to go through the investigation together. Normally I would be picking on somebody to read that for me, but you can follow along. I'll read it with you. So it says fraction manipulatives make it easier to understand fractions because you can move things around and you can physically see if I stack 2/8 on top of 1/4, they match up. So we will illustrate that in a little bit. And it says fractions can be reduced. This is going to be coming up in lessons in a couple of weeks, but fractions can be reduced. So 2/4 is the same thing as 1/2. 1/2 just uses smaller numbers to state the same fraction. And then both name the same portion of the whole, but 1/2, it says just uses smaller numbers. That math language sidebar says to reduce a fraction is to rewrite it using smaller numbers without changing the size of the fraction. So if I had 2/4 in my manipulatives, so I've got 2/4. I put some sticky tack on it. I'm hoping that works with my whiteboard. I really miss my document camera. 2/4 is the same as 1/2. If I could Well, the sticky tack doesn't want to stick on here very well. So that's, you're going to have to kind of bear with me and imagine what I'm trying to show you. So 2/4 is the same as 1/2, but 1/2 is using smaller numbers than 2/4. So using manipulatives, activity number 1, use your manipulatives to answer the question. So it says 1/4 equals 1/4. How many quarters make up 1 whole? So you'll take your quarter manipulatives, your 1/4 manipulatives. I colored those in with pink colored pencil. And I didn't color very dark because I wanted to still be able to see the numbers, and so it's not showing up very well. I'm going to leave those 2/4 that I have up there. Did I make a whole yet? No, that's only half of a pizza. So I'm going to get another 1/4. And I'm going to get another 1/4. And now I have an entire circle, an entire pizza. So 4 quarters make up 1 whole. Now the second problem is, or the third problem is one that's going to be using mixed numbers, because it says how many fourths equal 1 and 1/4. So that means if I have an entire whole, so I'm going to leave those fourths up there. That's not 1 and 1/4, that's just 1. So I'm going to reach into my bag that has my old ones from last year. We're not colored in. I'm going to get one more fourth in here. So here I have 1 whole pizza and I have 1/4. I've got 1 and 1/4. How many quarters is that? 1, 2, 3, 4, 5. So my answer is 5/4 are equal to 1 and 1/4. This is kind of using manipulatives to show what we went over in lesson 89. We were just drawing in lesson 89. This time we're moving things around on our board. Number 4 wants you to write a number sentence or an equation that shows how to make a whole using only quarter pieces. And they started us off and they said 1/4, and that says plus 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 equals 1. This is backwards for me when I'm looking at it. So it would be 1/4. I've got my 1/4 on here. 1/4 plus 1/4 plus 1/4 plus 1/4 equals 1 whole. All right, we're moving on to that next page of your investigation. I feel like this video is more boring though, because I'm not just teaching something. We're going through stuff together like we would in class, but we're not in class, so you aren't in groups using manipulatives together. We aren't going through things together. I'm not getting to see on your face when you push those manipulatives together and you see that they make a whole. That's the best part of teaching, is getting to see when something clicks, and I can't do that right now. So this feels very, I'm not feeling so great about how this lesson is going right now, but we're going to do what we have to and try and make things work out the best that we can. All right, number 5 says how many halves equal 1 and 1/2. So I'm going to get my half manipulatives. I colored these in orange. So I want 1 and then 1/2 more. So I'm going to put up enough halves to make 1 first. So I've got 1, but that's not enough. I need 1 and 1/2. So I'm going to add an additional half to that. Get my sticky tack. I have 1 and 1/2. How many halves is that? 1, 2, 3. So 3 halves equal 1 and 1/2. Then number 6 says 4 halves will make up how many wholes? So it's a good thing I've got 2 of each set of manipulatives for this. Normally you'd be doing that together in your desk group. So I've got 4 halves up here now. How many wholes do I have? I have 2 halves makes 1 whole, 2 halves makes 1 whole. I've got 4 halves or 2 wholes. All right. Now we're going to get into some least to greatest problems, and I wonder if you guys remember the cheat codes that I told you for comparing fractions, because we've already done this section in power-ups before, even though we hadn't gotten to it in the book. So it wants 1/2, 1/8, and 1/4 written in least to greatest on your page for number 7. So I have a 1/2 manipulative still up here. I'm going to get a 1/4. And I'm going to get a 1/8. All right, I've got 1/2, 1/4, and 1/8. So which one would be least means smallest? Which one of those is the smallest piece of pizza? 1/8. Which one's in the middle? 1/4. Which one's the largest? 1/2. So really these are actually in opposite order. Actually, it should fit. Switch those around. So 1/8 is going to be the smallest. Then 1/2, then 1/4, then 1/2. Then it wants greatest to least, but this time they're not just 1 for the numerator. These ones all had 1 for their numerator. The denominator changed. This time I'm going to be changing it. It says 3/8, 3/4, and 1/2. So I don't need anything else added with my half, but I need to add 3 more 8 pieces. So I've got 3/8 here. And I need to add 2 more quarter pieces, so I have 3/4. All right, so here I have 3/8, 3/4, 1/2. Now, which one is the largest? See, I'm going to compare this. I take the half and I hold it over this. It covers some of the 3/4, but not all of it. So actually 3/4 is larger than 1/2. And then I'm going to look at the 3/8. There's still 3 of them, but those pieces are smaller. So 3/8 is going to be the smallest. It's actually going to be 3/4 is the largest, then 1/2, then 3/8. So 9 and 10 have some comparative fractions. I'm going to take these off and I'm going to write down those examples on the whiteboard. So they have 2 halves and then they have 2/4. Now, we talked about how to do this by cross multiplying, but they want us to be thinking about this manipulative wise. So 2 halves compared to 2/4. Now, if I do 2 times 2, I've got a 4 over here. If I do 4 times 2, I've got an 8 over here. Which one's larger, 8 or 4? 8 is larger. Same thing as if I had 2 halves or 2/4. Now, this helps illustrate number 12, which is on the next side. If numerators are the same, the fraction with the greater denominator, these had the same numerators, 2 and 2. The fraction with the greater denominator, so that's the 4, is the smaller fraction. It kind of messes with your head a little bit because you're thinking it's a larger number. It should be a larger fraction. It's not, because this means I had 2 pieces and I ate them both. This means I had 4 pieces and I ate 2 of them. So the smaller fraction is going to be the one with the larger denominator only if the numerators are the same. Now we're going to look at number 10, which is going to help illustrate number 11. Number 10 says 4/8 and 3/8. So I'm going to compare 4/8 and 3/8. Now, if I wasn't sure, 8 times 3 is 24. 8 times 4 is 32. Which one's larger? 32 is larger than 24. So 4/8 is larger than 3/8, but I'm also going to illustrate that with manipulatives. So I'm going to put 4/8 over here. Got 4/8. I'm going to put 3/8 over here. These pieces are all the same size because they are cut into equal pieces in those pizzas. So 4/8 is going to be larger than 3/8. If the denominators are the same, the fraction with the greater numerator is going to be larger. If the denominators are the same. So if the denominators are the same, the larger numerator is the larger fraction. If the numerators are the same, the larger denominator is the smaller fraction. All right, we're going to go on to number 13, where they want us to be doing some reducing of fractions. And then we're going to move on to adding and subtracting fractions. And those are things that you guys are already really good at because we've been doing that for a long time already with our power-ups. So number 13 says 2/4 is the same as how many halves? Can be reduced into what? How many halves? So we already did that one earlier. 2/4. I'm going to put 2/4 up here. It wants me to reduce it to a fraction with halves on the bottom. So I'm going to get out my halves. I'm going to see how many halves does it take to cover that up. Oh, 1/2 covers those 2/4 perfectly. So 2/4 is equal to 1/2. Number 14, 2/8 is equal to how many fourths? So I'm going to get 2/8 up here. I'm going to get a fourth. I'm going to see how that compares. Same thing as with the halves. I was able to cover up those 2/8 with just 1/4. So 2/8 is equal to 1/4. I'm going to leave those eighths on there and add 2 more because the next question says 4/8 is how many halves. So I'm going to get 4/8 up here. Got 4/8. Then I'm going to get my half manipulative. And 4/8 is equal to 1/2. 16 and 6/8 equals how many fourths? I'm going to let you guys do that one on your own. We're going to move on to 17 where we are adding and subtracting. Now, the neat thing about this is they already are using only like denominators for these adding and subtracting problems. So you don't have to worry about the denominators at all when you are adding and subtracting. Remember, if it already has common denominators, you can just pay attention to the numerator if you're adding and subtracting. Multiplication, division, different story, but we're adding and subtracting. I can kind of ignore the denominator because I know the denominator is going to stay the same. 1/4 plus 2/4, I know my denominator is going to be fourths, so I'm really just thinking about 1 plus 2. So that's number 17. It has 1/4 plus 2/4 would equal 1, 2, 3 fourths, because they're still cut into the same amount of pieces. Number 18 is addition as well as just using eighths. So I'm going to skip over that one and let you do that on your own. Number 19, though, is subtraction. So I've got fourths again, but this time I'm starting out with 3/4. And it says 3/4 minus 2/4. Take away 2/4 equals 1/4. 20 and 21 are also subtraction with common denominators, so you can do that one on your own. We are ready to move on to activity number 2 for the investigation. This is when we're going to be looking at how the fractions, decimals, and percentages are all equivalent and how we would work with those. So it says fractions and percents are related. Same thing with decimals. Decimals are just having denominators of 10, 100, or 1,000. They're always denominators. There are multiples of 10. That says 1/2 equals how many percents? So I'm going to look at my 1/2 manipulative. This is 1/2. And then it says that this is the same thing as 5/10, and it's the same as 50%. So 1/2 equals 50%. Number 23 is dealing with what percent is equal to 1/4. You're going to do that one on your own. I want to look at 24 because that one says what percent is equal to 3/4. So what I'm going to do is I'm going to get 3/4 up here. I've got 1/4, 2/4, 3/4. Now my 1/4 manipulative says that each fourth is the same thing as 25%. So when I have 3/4, I have 25% plus 25% plus 25%. So 25 plus 25 plus 25 if I want to do repeated addition, or 25 times 3 if I'd rather do multiplication. 3/4 or 3/4 is going to be the same as 75%. Number 25 through 27 is looking at your manipulatives and writing down the decimal that matches. So we just now looked at percentages. We said my 1/2 is the same thing as 50%. Now, number 25 says 1/2 is equal to what decimal? And that would be 0.5, which is the same thing as 5/10. So 1/2, 5/10, and 50% are all equivalent. 26 and 27 are asking for the equivalent decimals that match with the 1/4 and 1/8. So now we're looking at 28, and it says compare 5/10 to 2/10. And we went over this in lesson 90, comparing decimals. We were using money manipulatives for these. If they are the same place value, I can just look at whatever the larger number is. So I know that 5/10 is larger than 2/10. They're not going to a different place value. That one's easier. It gets confusing if I have some zero placeholders and a different place value in there. Kind of like if we're looking at number 30, and I have 125 thousandths, and I'm comparing it to 25 hundredths. Now, I might automatically want to say, hey, definitely the 125 thousandths, that goes into 3 place values. Thousand sounds like a lot. Sounds like more than hundredths. This only goes 25 hundredths. But if I look at my manipulatives, see, my 1/8 is the one that says 0.125 or 125 thousandths on it. And my quarter manipulative is the one that says 0.25 or 25 hundredths. And even though thousands sounds like it's more than hundredths, I can see when I use the manipulatives that actually 1/4 is larger than 1/8. 25 hundredths is larger than 125 thousandths. Now, 31 is similar to when we were comparing fractions to see which one was the largest, but this time we're comparing them by their decimal number. So it says 0.5, 0.125, 0.25. So 0.5, 5/10, that's my half manipulative, my 1/2 manipulative. Then it says 0.125, 125 thousandths, that's my 1/8 manipulative. And then it says 0.25 or 25 hundredths, that's my 1/4 manipulative. And it wants them arranged greatest to least. And I actually already have the greatest one first. By coincidence, 5/10 or 0.5 is the largest. These two need to be flip-flopped. 25 hundredths, we just did that in our comparison, is larger than 125 thousandths. So it's going to be 0.5, then 0.25, then 0.125. Now 32, take 2 1/4 pieces and 1 1/2 piece. So I'm going to get rid of my 1/8, keep my 1/4 up there and my 1/2, add 1 more 1/4. It says notice that 1/4 plus 1/4 is the same as 1/2. We already went over that, but they want to write that as a number sentence or as an equation using the decimal point. So they started us off with 0.25, 25 hundredths, plus another 25 hundredths equals 1/2 or 0.5, 5/10. Now, in my opinion, when it's decimals, it's easier to not use manipulatives. It's easier to just write it out. That's just how my brain works. Your brain is different than my brain. Everybody learns differently. But if I had 0.25 in an equation plus 0.25, it would be easier for me to bring down that decimal point and see that it's 0.50. Remember, zeros after the decimal can be placeholders. So 0.50 and 0.5 are equivalent. So 25 hundredths plus 25 hundredths equals 5/10. It would be easier for me to figure that out writing it. Maybe that's not how it works for you. Maybe using those manipulatives was helpful. That is okay, whichever way you do it. The rest of your investigation is using those manipulative pieces like we've been doing, and they want you then, they'll give you an equation like 1/8 plus 1/8 plus 1/8 equals how many quarters, and then they want you to write it using percentages, or they want you to rewrite it using decimals, or they'll give you a number sentence using decimals or percentages, and they want you to transfer it into fractions. The last thing that I want to look at, though, is they are using whole numbers and subtracting fractions, and we've done that, but not the way that they have written this out. So we have done fractions equal to 1 and then used that to subtract. We haven't done subtracting just from a straight up whole number. So number 37 says start with 4 1/4 pieces. So I'm going to get my 4 1/4s up here. All right, then it says take away one of the 1/4 pieces. Here's a fraction number sentence for the subtraction, and this is the number sentence that they give you in the investigation. They say 1 minus 1/4 equals, and I'm going to count that up, 1, 2, 3/4 are left. The way we have done this before now is we said anytime that a numerator and a denominator match, that's an equivalent fraction to 1. So we wouldn't have written down 1 minus 1/4 equals 3/4. What we would have had written down before now is we would have seen 4/4 minus 1/4 equals 3/4. So we've seen that before. Here's 4/4. Take away 1/4 equals 3/4 that are left. But when my numerator and my denominator are exactly the same, when I have 4/4 or 5/5 or 12/12, it's the same thing as having one whole. 1 minus 1/4 equals 3/4. You are doing similar problems to that for 38 and 39, and then the investigation is finished. Most of those we went through together. A couple of them you need to go back and reuse the same concept just to finish it on your own. This is a longer video. Investigations usually are very long, but we usually go through them entirely together in class. And so this is basically an entire class period instead of a mini lesson and time to work on problem sets. So next week on Monday, on April 6th, we will be going over the first lesson from your second packet. They are available outside the classroom right now. I've also sent them to your parents electronically. The second packet looks like this. It has your Christ-like stories on the top. And then after you go through all the Christ-like stories, then it has math. It starts with lesson 96 on averages. Normally we would combine 96 and 97 together. So it's going to be one video, but I'm going to go through one a day. So we'll do 96 on Monday.